Hi, this is Sophie Davis, and today I'm going to be explaining question 6 from exam 2 from the spring 2013 semester of CSE2. So this is question 6. It reads, convert all the following loops into code that uses for loops to produce identical output. Replacing nested loops with single loops is acceptable as long as the output remains identical. Hint, make sure you know what the output is before you start. 10 points each, 20 points total. So here we're given a snippet of code, and here we have a do-while loop, and we're asked to translate it to a for loop. So this question is focusing on translating loops from one to another, and it really tests your understanding of how loops run and how they work. So we're going to try to read through this and get the output of the original loop. So in order to do this, we're going to walk through the code step by step and record each number that is outputted. So here we start with integer x equals 5. So for the do while loop, we have integer x equals 5, and here we're told to increment x by 2. So x becomes 7, and then we have a print line where this will print out, x will print out, and then the do closes and the while is the conditional. So here x is 7, so it's still less than 10, so it'll execute again. So here we have our first output, which is 7. Okay, so now x is 7, and we go through the loop again, increment x by 2, so x becomes 9. We print out 9. 9 is still less than 10, so we have our second output of 9. And then we go through again with x equal to 9. So x equals 9, 9 plus 2 is 11. We print out 11 on a new line. And here x is greater than 10. So we exit the loop and we're done. We have all our outputs. So the outputs are 7, 9, 11. So we have our original outputs, and we want to get those outputs out of our second loop. So now we can start translating it. So for the for loop, it declares a little bit differently. So the way the do while loop works is that it will always execute once because the conditional is at the end. So it checks for the conditional at the end. So, like I say here, the do while loop is always executed and prints at least once, and then checks the conditional at the end. So this means we're going to have to alter some of our conditionals when we start writing our for loop. So we're going to start with for, and then we have integer x. So we're going to do integer x but because this is run, the first time this is run, x is printed out as 7, we're going to start x at 7 in the for loop. So we're going to set x equal to 7. And we're going to have to alter our range a little bit too, because we only want it to run 3 times. So in order for it to run 3 times when it's starting at 7, we're going to have to increment this by 2 so that we can print out 11, which is our final output. So we're going to set x less than 12. And finally, here we have x incrementing by 2 each time the code runs. So we're going to apply that to the same statement to the for loop, and we're going to increment x by 2 every time the code runs. So we're going to write x plus equals 2. And we're going to open our curly bracket. So once we're inside the for loop, we're just going to print the value of x because that's what the do while loop does. So system.out.print line x, and then we're going to close the loop, and that's it. That's the translated loop. So we're going to test through this to make sure the output is correct. So we're going to start, remember we want our output to be 7, 9, 11. Okay, so we're going to run through this. X equals 7, x is less than 12, that's true, so we're going to run. So x is equal to 7, we're going to print out 7. So our first output is 7. Okay, now we're going to increment x by 2 because the code was run once. So now x is equal to 9. And we're going to print out 9 because 9 is still less than 12. Okay, so we have our second output, 9. We're going to increment x by 2. So x is going to become 11 because 9 plus 2 is 11. And 11 is still less than 12, so this is still true. This still applies. So we're going to run the code again. And we're going to print out x again. So our third value is going to be printed out as 11. All right, and then we're going to increment 11 by 2, so that's going to be 13. But 13 is not less than 12, so we're done running the code. And the loop has been exited. So we have the same output for our original loop and our second loop. So a common mistake that people make, I've kind of highlighted already, but the do while loop always runs once. And so translating this is not as simple as just going from a while loop to a for loop where the conditions and the starting value of the variable will often be unchanged, because here you have to take into consideration the fact that it does run once, so with before it's checking the conditional. So numbers are going to have to be altered so you can get the same output. So to prepare for this kind of question on an exam, I would recommend just translating between loops and just getting really comfortable with it. So going from do while loops to while loops to for loops to do while loops, and just getting comfortable with translating back and forth so you really understand how the loops run and how the outputs are produced. And now we're going to move on to part 2 of question 6, and here we have a nested while loop that we're going to translate into a for loop. So we're going to do the same thing and walk through and get the output from this one so that we can make sure that our new loop generates the same output. Okay, so we're going to start reading the code. So integer I 0, j is 20. So I is less than 30, that applies. So we're going to go into the inner loop. J is greater than 0, which applies. So we're going to go into the innermost loop, and we're going to print out I plus j. So right now I is 0 and j is 20. So we're going to print out 20. So here we have our first output, 20. And then we're going to decrement j by 4. So j is now going to be 16. So j is still greater than 0. So j is now 16. And we're going to do the print line. So I is still 0 and j is 16. So the next output is going to be 16. So our second output is printed out. Okay, then we're going to run it again, decrement j by 4. So j is now 12, which is still greater than 0. So we're going to print it out again. 0 plus 12 equals 12. Decrement j by 4. J is now 8. 8 is greater than 0. 0 plus 8 is 8. And lastly, we have j decremented by 4 again. So j is now equal to 4, which is greater than 0. I'm going to print out 4, and when we decrement j again, it's going to be 0, so this is no longer going to execute because j is equal to 0. So we're going to go back out to the outer loop. So we're going to increment I by 4, so I is now equal to 4. 4 is less than 30, we go into the inner loop. J, however, is still equal to 0, so we can't run the inner loop because j is not greater than 0. So we go out again, increment this, it's going to become 8, same thing applies, the inner loop doesn't run, so this is going to become 12, 16, 20, 24, 28, and then eventually it's going to be greater than 30, and we're going to exit the loop. So our final output is just 20, 16, 12, 8, 4. So now we're going to translate this to a for loop. So if you think about it, we can easily generate a single for loop that's not nested that can print out this output. So our first output's going to be 20. We want to set x equal to 20. And we want x to be greater than 0 because our last output is going to be 4, so x is greater than 0. And then we're going to decrement x by 4 each time. So we're going to put x minus equals 4. Okay, open that up. And then we're just going to print out x. So system.out.print line x. And then we're just going to exit the loop and let's see if we can generate the same output from this. So we went through once, x equals 20, x is greater than 0. So we're going to print out 20. All right, decrement x by 4. We have 16. 16 is still greater than 0, so we print out 16. Decrement by 4, x is now equal to 12, which is greater than 0. Going to print out 12. Then x becomes 8, which is greater than 0. We're going to print out 8. Then x becomes 4. 4 is greater than 0. We're going to print out 4. And when we decrement 4 by 4, we're going to get 0, which is not greater than 0. So we're going to exit the loop, and we're done. So we have identical outputs. So this loop is successful. I'm Sophie Davis, and this is CSE2.